that's nice. This is the brand new RTX Pro 6000 and it's heavier than it looks. Still pretty hard to get these. I had to make multiple phone calls, multiple email communications to get this card. But today I'm going to be comparing it against well, not this one. This is just to show scale. This is the RTX 3050 low profile. Here's the 5060 Ti. Here's a 5090. And here's the RTX Pro 6000. So it's not going to take up that much space in our little AI machine here that I built recently. I want to see how many tokens per second we're going to get and whether it's going to be worth it, because the price on this thing is not cheap. And of course, I bought all these cards myself. NVIDIA did not send these over to me. So if you were really, really serious, you can get a stack of these. Since they're 96 gigabytes of VRAM each, you can probably get 4 of them and run DeepSeek on there really fast. Let's see if it can avenge the 5090 from a few weeks ago when I pitted that against the M3 Ultra Mac Studio. The 5090 has 32 gigs of VRAM. So you need 3 of these to have the same VRAM as one of these. You can run models on the 5090 very successfully. Models that are maybe 12 billion parameters, 32 billion parameters quantized down, but 70? No. What happens if you run a 70 billion parameter model? Well, here. Not as much GPU usage on this one. Yet, we got 7 tokens per second instead of 1.8. Yeah, 1.8 tokens per second on the 5090. Unacceptable. Let's not forget the power cable and display port. There's 4 display port connections on there. Let's pop this thing on. Whew. You hear that? So right now the machine is on and it's using about 90 to 100 watts of power just sitting there. Now I am on Linux here. This is the model that I ran on the 5090 that gave us a really bad tokens per second. And the reason I did that, by the way, is because not everything fit in VRAM. So some of it have to be offloaded to the CPU, and running it on the CPU is just really slow and you don't want to do that. So I'm going to offload all 80 layers out of 80 to the GPU here and load this model up. Now here you can see the model is loaded. It is 39 gigs on disk, but it's 43 here in the VRAM. It's all loaded into the VRAM now. That just looks beautiful, doesn't it? 95.5. What happened to the 0.5 gigabytes, huh? Did I get ripped off? This card is capable of running 600 watts. 600 watts means it's going to use the full power that this card is capable of. That's the maximum, and that's going to be the most performant. It's going to be the fastest. You can set it to 300 watts if you're sitting next to the machine and you don't want it to make too much noise, but then it's going to be slower. All right, here we go. We're going to start with a small 1 token prompt. I know a lot of you want to see a longer prompt, and we'll do that. But 1 token prompt, the smallest possible processing that's going to be involved here. So it's going to show us the fastest possible results. Let's go. Boom. That's pretty good. I'm getting 31.89 tokens per second here. 5090 has been vindicated. Now there's a small difference in the number of CUDA cores between the 5090 and the Pro 6000 also. The 5090 has 21,760 CUDA cores and the Pro 6000 has 24,064 CUDA cores. That's a pretty significant bump. Even if we're running smaller models, this should be faster. So let's do that. I'm gonna load up Llama 3. We're gonna get bigger models too, don't worry. We're offloading all the 34 layers. Let's go. Load it up, start a new conversation here. And let's say hi here. Now, before I do that, any guesses? Also, just to give you a little context. The 5090 did about 93 tokens per second here, and so did the M3 Ultra. Maybe a few tokens more per second there. But let's see what this one does. Boom. Okay, 215 tokens per second. That's just insane speed. Let's get serious and load something big. We want to really push this thing, don't we? That's why you buy something like this, is for its memory capacity. And you'll see here that 70 billion parameter models can come in a couple of different flavors. First of all, there's the architecture difference. But even if you just ignore the architecture and just look at the number of parameters, 70 billion, they have different quantization levels. So here's a Q4, and those come in at around 40 gigabytes in size. We still have plenty of room to go on that. Then you have Q8, and Q8 is now gonna be 70 gigabytes for this particular one. Llama 3.3, 70 billion instruct. Q8 means quantized to 8-bit instead of 4, which is still quantized model, but not as much. Theoretically, it has better performance in terms of the quality of the output, but not necessarily so, depending on a lot of different factors. That's not the point of this video at all. And you can see that LM Studio is trying to offload 66 out of 80 layers to the GPU. Why? why not offload all of them? Well, it's being a little bit careful here. And if we offload 66 out of 80, we're gonna get terrible performance. I'm telling you that right now. Let's do that. Why is Alex doing this terrible performance thing? Well, it's a demonstration after all, right? I want to show you how much we can gain by offloading all the layers, which this GPU is now fully capable of doing. We're going to offload probably 2/3, if I'm doing my math right, maybe 3/4. Somebody will correct me in the comments, of the model to the GPU, and the rest of it will be on the CPU. And that's going to be just not good. Hi. Look at that. Look at that. It's just thinking about it, and that's gonna... How's it going? Is there something I can help you with? 3 tokens per second. Terrible. Terrible. Eject that. Get out of here. Let's go with the same thing, but we're gonna do 80 out of 80 layers offload. This is exciting. I'm gonna do a little aside here, and I'm gonna tell you that this is an expensive card. And I don't even know if I want to keep it or not. I mean, I have to keep it because there's no returns. The channels that I got, it's not like you buy it on Amazon but I could sell it, right? I can sell it on eBay. There's still quite a bit of a markup on this. But I'm telling you, I've never had a card like this. And this is just insane. To be able to load 96 gigabytes into VRAM is just... Okay, aside over. That was so that I can load the model and talk to you while it's loading. Holy cow, 20 tokens per second. Wow. Now, since we're here, I want to do a longer prompt and show you the difference. This is a 205 token input. You're a senior software architect tasked with designing a scalable, fault-tolerant, multi-tenant platform. Your responsibilities: describe CI/CD, explain your performance, propose plugin systems, provide a working example in TypeScript, and justify every trade-off. This is not an implementation type of prompt, more of an architecture type of prompt. And there it goes into excruciating detail. Power is 515 out of 600 watts. So we're not quite at 600, but it's definitely way more than 300. All right, 18 tokens per second, about the same. Jumping in here real quick, I do have a comparison of this card with all these other cards coming up later in the video, but I had to buy all these expensive cards myself, so here's the sponsor of this video. So these days, I'm constantly flipping between models. GPT-4o for notes and email, Claude for code refactors, Flux for image generation, Kling for video, 4 tabs, 4 bills, and counting. Enter Chat LLM Teams. There's one dashboard that houses every top LLM, and Route LLM picks the right one for you for a given task. O4 Mini High for fast answers, Claude Sonnet 3.7 for coding, Gemini 2.5 Pro for big context, and even adds GPT 4.1 before ChatGPT has it. Chat with PDFs and PowerPoints, then generate decks and docs and do deep research all in the same chat. Need human-sounding copy? The Humanize toggle rewrites text to beat AI detectors. Spin up agents and run code with AI Engineer. I built my first bot in just minutes. Track artifacts, create GitHub pull requests, and debug from the same interface. Need visuals? No problem. Use Flux or Ideogram and Recraft for images, Kling, Luma, and Runway for video, all built in. And the kicker is just $10 a month, less than one premium model. Head over to chatllm.abacus.ai or click the link in the description and level up with Chat LLM Teams. Now, since we have this kind of capacity in here, we could run floating point 16, an FP16 model, which means it's pretty much unquantized. And I have here Qwen Coder 32 billion instruct FP16. That one is 61 gigabytes on disk. So let's load that one up. Let's do a high and then we'll do the other one. 23 tokens per second here. This is the FP16, not quantized. So it's pretty nice. Anything above 20, that's pretty good. If you're getting into 80, that's like really good. So let's do that long prompt again and see what we get here. Token generation speed should not really matter that much. If you're doing a short prompt versus a long prompt, the difference will be seen in time to first token. The processing is going to take longer if it's a longer prompt. So while I was doing that, I also want to generate a really long prompt. Give me an example of a highly complex prompt that would request software implementation details for a backend engineer that uses Python. The prompt should be at least 4,000 tokens. And I asked O3 that so that maybe we'll actually get it. We'll see. Now for that one is 22 tokens per second for the long prompt, so about the same as our short prompt. Now the processing time here was 0.08 seconds to first token, negligible. We'll come back to that. This one is F32, 2 times the size of the FP16, the floating point 16. This is a 7 billion parameter model that's 27 gigs on disk, and we can offload everything. So it should be not a problem to load this. On high, we're getting 51 tokens per second. Now, I didn't run any of these FP16 or F32 models on my Apple Silicon machines. So here I've got my daily driver M4 Max, and the memory bandwidth on these machines on the M4 Max chip is about 500 gigabytes per second. And that's really, really good. It's not like the M3 Ultra. That one is over 800 gigabytes a second, which I don't have anymore because, well, I didn't use that machine. I didn't really need it, so I got rid of it. So I can't run this exact test on that machine. But here is the M4 Max version of the Qwen 2.5 Coder 32 billion FP16, and I'm gonna say hi to it. Hello, how can I assist you today? Blah, blah, blah. 7.63 tokens compared to the 22 that we got on the RTX 6000. What about the Mistral 7B? F32. Let's check that one out. By the way, everything fits nicely into this because this is the 128 gig machine. So by default, it's gonna have pretty much the same VRAM available, about 96 or so. You can allocate a little bit more by giving a command. Not gonna go into that in this video, but basically they can fit the same kind of models. However, we're seeing that there is a big difference in the performance of these. So I'm saying hi now, and I'm getting 18 tokens per second on the F32 compared to the 51 tokens per second on the RTX 6000. Whew, it's getting really toasty in here. 03 finished, and it gave me a download link because I guess the prompt was gonna be too long to display. Holy moly, look at that prompt. Okay, this is gonna be crazy. Let's copy this into LM Studio and see how long the prompt is. 35,000 tokens. It did not follow directions, but it's an interesting experiment. What would happen if we give a 35,000 token prompt? Hey, you all wanted longer prompts? Here you go. Let's go to new chat and paste that puppy in. I have a feeling this is just gonna say, nope. Nope. And yeah, that's what happened. Trying to keep the first 35,000 tokens when context the overflows. What? That doesn't even make sense, that message. Anybody listening from LM Studio? You should fix that message. What's up? I'm gonna tweak this a little bit. This model doesn't even support a longer context than 32,000 tokens. So let's find a model that supports a longer context first. And Gemma 3 12 billion does support that. And I believe the QWQ 32 billion also supports it. But you know what? I wanna get as close as possible to our memory limit. Yes. Qwen 2.5 Coder, 32 billion instruct, Q8, and this one is 65 gigabyte size model. So I'm gonna increase the context length quite a bit. Even though it's 65 gigabytes on disk, this model is gonna be much larger when it's loaded into VRAM because the context length that I'm asking it to support is gonna be much larger. Let's go with 40,000 or thereabouts. We do get a warning. Setting a high value for contact lens could significantly impact memory usage. Yes, I know. Don't show that again. Okay, GPU offload is going to be 64. Load model. Boom. Let's see if this even loads. Hopefully it does. I think it should. Let's start a new chat. And this will be a record. I've never submitted such a long prompt before. It's a ridiculous prompt, but think about it this way. If you're using this device, you're probably not going to be chatting with it. You're probably going to be using this somewhere else in the office on a separate machine, and you're going to be connecting your LM Studio via a server. LM Studio exposes a server right here that you can turn on, and then you can talk to it via API. I've made several videos about that on this channel for the members of the channel. By the way, if you want to join, there's a join button right down below. We do all kinds of crazy stuff, experiments, extra videos, things like that. And you can see that 74.9 gigabytes is now being used. We still have some space. Let's post that prompt in there. And it's doing it. It's processing the prompt. Look how slow that is because it's such a huge prompt. The fan just went up. I'm hearing little tinkle, tinkle, tinkle sound of that coil whine. By the way, the coil whine on this thing is very noticeable. It's still processing the prompt. That's crazy. Here we go. It's creating a comprehensive implementation plan, and now it's spitting out the result. So this speed right here, the actual output of the tokens is going to be about the same as we've seen before for this model, but it's that initial hit of that prompt processing that's going to be most noticeable. And where that matters is if you're working on a code base and you're submitting it through an agent, for example, you want to send a bunch of files over to the LLM to process it, then you're going to accumulate pretty large context. And that's where this thing really matters. So how long is it going to take you to get that result from the LLM for your agent to keep chugging away? Or maybe you're just chatting with it. I don't know. That's fine too. It's okay. You can chat. Oh wow, it's getting really, really warm in here. Card is okay to touch. This right here, these are vents that are blowing out very warm air right now, and they're blowing it on me, so I don't like it. If this card was inside of a case where that vent was blocked, you'd be in trouble. So I'm glad that I have an open case here, because normally it wouldn't be. 17 tokens per second here, and time to first token was 29.9 seconds. Notice that my context is only 83% full. After all that text, that's wild. That is a very long answer. I'm not gonna read it. I'm just gonna throw it away and think that you gave us a really good plan. I also wanna compare all these cards to each other. So I'm gonna do that one at a time. Might take me all day. All right, it's done. Let's take a look at the results. How about this one, 70 billion parameter? Oh, well, surprise, surprise. There's only one value for that because only one of these cards is capable of running that model. Obviously, the Pro, 33 tokens per second. That's pretty good. This other llama, this is the Q8 version, and look how much slower that is. 20 tokens per second on this one. What else can only this card run? Well, this 32 billion parameter model, well, actually two cards can run that one. So here it is relative to each other. We've got down here the Q8 of llama 70 billion, llama 70 billion Q4, and then also on the same card on the Pro, QWQ32B Q4. Sorry for all the Q's in there. This one is 60 tokens per second, but look at this. RTX 5090 also ran this one. You can tell because of the number of gigabytes of memory. So that's 32 gigs of memory right there. And this one was faster. The 5090 is faster than the Pro. I wonder if that's just a fluke. Let's take a look. Let's take a look at some of these other smaller models here. Well, here's another one. Llama 34 billion. It ran on all the machines. And obviously over here, the slowest on that's the 5080. That's the 16 gigabyte 5080. It ran it at 119 tokens per second. Then we have a big jump to 183 tokens per second. Do both these 5060 Ti and the 5080 have 16 gigs of memory? Interesting, but here's the more interesting part. Here's the 5090, 239 tokens per second, and the RTX Pro 6000, 233. A little bit slower than the 5090. Let's add Llama 312 billion. 50 tokens per second on this one, 88 tokens per second on the next card. Look at that curve. That curve looks almost exactly the same as the other Llama. And then we've got 127 tokens per second on the 5090, 124 on the 6000. Another one with a similar curve. This is the 1 billion parameter model. Wow. 229 tokens per second on the smallest card, and all the way up to, here's the medium card, 299 tokens per second, all the way up to 365 tokens per second on the 5090, 352 on the 6000. Folks, are you seeing a pattern here? I'm starting to see a pattern. How about this one? Same pattern. Wow. DeepSeek Distill Qwen 7B, 213 on 5090, 208 on 6000. Obviously, Llama 4 Scout only can run on the big one. That's 85 tokens per second. Llama 3, same pattern. 5090 is a little bit faster. Qwen 2.5 Coder, 5090, 6000. This is the FP16. It could only run on two of the machines. Here's the 5090. This is an interesting departure from our pattern because now the 5090 is slower. 51 tokens per second on the 5090, 51.4. Because of the way this chart is drawn, it looks like a bigger difference than it is. Actually, they're very close. F32 for Mistral 7B, 52 tokens per second on the 5090, 53.6 on the 6000. So the FP16 and the F32 models are actually about the same or maybe a tad bit faster on the Pro 6000, but all the other models, all the smaller models, are faster on the 5090. And of course, here's Qwen 2.5 coder, 32 billion, can only fit on that larger machine, 24 tokens per second there. And Qwen 2.5 coder, 32 billion, that's quantized to 4. The Q4s are faster on the 5090 than on the Pro. Interesting finds, and I don't know how to explain it. Considering the Pro board has more CUDA cores, it should be faster. Maybe it has something to do with cooling. Maybe it has something to do with not using all the full potential power that this thing can handle. For one reason or another, the 5090 is faster at most of the things that I would typically run, which is the 8 or 4-bit quantization level. Can't explain this. You got any theories? Now let's do a quick analysis of what we've learned so far. And I'm gonna base it on the fastest speed that we saw from this RTX machine, which was 215 tokens per second, where the M3 Ultra got 100 tokens per second. First of all, the M3 Ultra Mac Studio cost 10,000 bucks. The retail value of this card, let's take a little range there between 7,500, which is what I paid for it, and 11,000, which is the retail price. And let's take the tokens per second per dollar calculation here. Even at full price for this RTX machine, we're still at almost 2 times the value that we're getting from the Mac Studio. If you watch this channel, you know that I use a Mac. It gives really good performance, but I always believe that CUDA-based machines like this one are actually much faster at doing this kind of work. The limiting factor until now was the amount of memory that you have. The 5080 only has 16 gigs of memory. The 5060 has 12 Ti. 5090 has 32. That's very limiting considering we want to run larger models. Finally, 96 gigabytes. It's expensive, but it seems like it's pretty much worth the price. So why would anybody buy a Mac Studio? If you get the M3 Ultra, you can go up to 512 gigs of memory. You can run much larger models. We're talking about the full DeepSeek and still get not the best results. It's still kind of slow, but it works. Is it something I would personally use? No, I wouldn't. I would rather get 2 or 3 of these and run that much faster than running one Mac Studio. It's fun, it's interesting, it's amazing what Apple has done, and maybe with the M4 Ultra or the M5 it's going to be even better, more RAM, more capabilities, but for raw horsepower this is the way to go. In fact, if you don't look at the retail price and if you can get a deal on it, that's almost 3 times the value of the Mac Studio. Oh, and did I mention that this thing can actually run games? Of course, it's not the main reason why I got it. This is too easy. You can just fly into people in this game. That's amazing. Now, if you want to see more detailed testing on the 5090 with the M3 Ultra, watch this video right over here. Otherwise, thanks for watching, and I'll see you next time.